practice of using a whip, which is a short length of wire, to wire receptacles actually began in the early 20th century. Before that, receptacles were often connected using what are known as pigtails, which were simply individual wires spliced directly to the receptacle terminals. Looking back at the National Electrical Code, the 1940 NEC introduced a requirement for receptacles to be connected using a canopy. This canopy was a metal enclosure designed to cover the splice and to provide a terminal for the ground wire. Progressing further, the 1956 NEC allowed for the use of a whip to connect receptacles. According to the code, the whip was required to be at least 6 inches long and had to be secured to the outlet box using a strain relief. Then came the 1993 NEC, which continued to permit the use of whips. However, a new requirement was introduced stating that the circuit conductors be connected to the receptacle using pressure-type connectors. So, is this practice code required? The NEC mandates that all electrical connections be made in a manner that is mechanically secure and electrically sound. The use of a whip to wire receptacles aligns with this requirement. Now let's consider some of the benefits of using whips. Firstly, it provides convenience. This allows for easy replacement of receptacles without opening the circuit, which can save time and effort during maintenance or repairs. Secondly, it improves safety. Using whips eliminates the risk of drawing current through the receptacle break-off tabs, which can cause overheating and potential fire hazards. Thirdly, it provides improved circuit integrity. The use of whips ensures that the circuit remains energized even if the receptacle is removed. This is especially important in critical circuits where power interruptions could have serious consequences. In conclusion, the practice of using whips to wire receptacles has been an industry standard for decades. It provides a convenient, safe, and code-compliant method of connecting receptacles to branch circuits. When installing electrical devices, always adhere to the latest version of the National Electrical Code and any local amendments to ensure safe and proper installation. A deeper dive into the NEC will provide better clarifications. Let's delve deeper into the technical aspects and explore the relevant sections of the National Electrical Code that pertain to receptacle wiring and the use of whips. We will also consider some best practices for ensuring safe and reliable installations. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is updated every 3 years to reflect the latest advancements in technology and safety practices. While the NEC does not explicitly mandate the use of whips in all receptacle wiring situations, it does provide the framework for ensuring that all electrical connections are made in a safe and reliable manner. Article 110.14 the NEC addresses electrical connections, stating that all connections must be mechanically secure and electrically sound. This means that the connections must be able to withstand the stresses and strains of normal use and must provide a reliable electrical path. The use of whips, when properly installed, can help to meet these requirements. Article 300.11 the NEC addresses securing and supporting wiring methods. This section requires that all wiring be securely fastened to a building structure and supported at appropriate intervals. When using whips, it is important to ensure that they are properly secured to the outlet box and that they are supported in a manner that prevents strain on the receptacle terminals. Article 314.16 the NEC covers box fill calculations. This section specifies the maximum number of conductors and devices that can be installed in an outlet box. When adding whips to an existing box, it is important to ensure that the box is large enough to accommodate the additional conductors and devices. Article 406.3 the NEC addresses the installation of receptacles. This section specifies the requirements for grounding, tamper resistance, and other safety features. When replacing receptacles, it is important to ensure that the new receptacle meets all of the applicable requirements. In addition to the NEC, there may also be local codes and regulations that govern electrical installations. It is important to check with the local authorities to ensure that all installations comply with these requirements. When working with electrical wiring, it is important to follow some best practices to ensure safety and reliability. Firstly, always disconnect power. Before working on any electrical circuit, always disconnect the power at the circuit breaker or fuse box. This will help to prevent electric shock. Secondly, use the correct tools. Use the proper tools for the job, such as insulated screwdrivers, wire strippers, and pliers. This will help to prevent damage to the wiring and equipment. Thirdly, make secure connections. Make sure that all electrical connections are mechanically secure and electrically sound. Use wire connectors or solder to ensure that the connections are tight and reliable. Fourthly, protect the wiring. Protect the wiring from physical damage by using conduit, cable trays, or other protective measures. This will help to prevent shorts and other electrical problems. Fifthly, test the installation. After completing the installation, test the circuit to ensure that it is working properly. Use a multimeter or other test equipment to verify the voltage, current, and continuity of the circuit. Let's talk about the advantages of using pressure-type connectors. These connectors offer several advantages over traditional wire connectors. They provide a more secure and reliable connection, and they are less likely to loosen over time. Pressure-type connectors are also easier to install, and they can save time and labor. Remember, the NEC is not a design manual. It provides minimum safety standards. Electrical engineers and designers often exceed these minimums to provide more robust and reliable electrical systems. When designing an electrical system, it is important to consider the specific needs of the application. This includes the load requirements, the environmental conditions, and the expected lifespan of the equipment. Here are some additional considerations when working with receptacle wiring. When replacing receptacles, use the same type of receptacle that was originally installed. If you are upgrading to a different type of receptacle, make sure that it is compatible with the existing wiring and circuit breaker. When installing receptacles in damp or wet locations, use weatherproof receptacles and covers. This will help to prevent corrosion and electrical shock. When installing receptacles in hazardous locations, use explosion-proof receptacles and enclosures. This will help to prevent explosions and fires. Also, when working with aluminum wiring, use connectors and receptacles that are specifically designed for use with aluminum wiring. Aluminum wiring expands and contracts more than copper wiring, so it is important to use connectors and receptacles that can accommodate this movement. When splicing wires, use the correct type of wire connector for the application. There are different types of wire connectors for different types of wire and different sizes of wire. Using the wrong type of wire connector can lead to loose connections and electrical problems. When routing wires, avoid sharp bends and kinks. Sharp bends and kinks can damage the insulation on the wires and can lead to shorts and other electrical problems. When pulling wires through conduit, use a wire lubricant. Wire lubricant will help to reduce friction and will make it easier to pull the wires through the conduit. When terminating wires, make sure that the wires are properly stripped and that the terminals are tightened securely. Loose terminals can lead to overheating and electrical problems. After completing the wiring installation, inspect the wiring to make sure that it is properly installed and that there are no loose connections or damaged wires. Correct any problems before energizing the circuit. Also be sure to label all circuits and receptacles with their corresponding circuit breaker or fuse number. This will make it easier to troubleshoot problems in the future. A final word. Working with electricity can be dangerous. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Always follow all safety precautions when working with electricity. Remember, this information is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific recommendations regarding your electrical installations. Let's discuss the practical implications of these code requirements and best practices. Imagine a scenario where you need to replace a faulty receptacle in a busy office. Without the use of whips, you would have to shut down the entire circuit, potentially disrupting work for everyone in the office. However, with whips in place, You can simply disconnect the faulty receptacle and connect a new one without interrupting the power supply to the rest of the circuit. This not only saves time, but also minimizes disruption. Now consider a situation where a receptacle is located in a damp basement. If the receptacle is not properly protected, moisture can seep into the electrical connections, causing corrosion and potentially leading to a short circuit. By using a weatherproof receptacle and cover, you can prevent moisture from entering the connections and ensure the safety of the installation. Let's explore another example. Suppose you are working on a renovation project in an old house that has aluminum wiring. Aluminum wiring is more prone to corrosion and loosening than copper wiring, so it is important to use connectors and receptacles that are specifically designed for use with aluminum wiring. These connectors and receptacles are made from materials that are compatible with aluminum and will prevent corrosion and loosening. In addition to these practical examples, it is important to understand the potential consequences of not following the code requirements and best practices. For example, if you fail to make secure electrical connections, the connections can overheat and cause a fire. If you do not protect the wiring from physical damage, the wiring can short out and cause an electrical shock. By following the code requirements and best practices, you can minimize these risks and ensure the safety of your electrical installations. Also consider the importance of proper grounding. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electrical shock. When installing receptacles, it is important to ensure that they are properly grounded. This can be done by connecting the grounding wire to the grounding terminal on the receptacle. The use of appropriate tools is another important aspect of electrical safety. Using the wrong tools can damage the wiring and equipment and can increase the risk of electrical shock. For example, when stripping wires, it is important to use wire strippers that are the correct size for the wire. Using the wrong size wire strippers can damage the insulation in the wire and can lead to shorts. The importance of labeling circuits and receptacles cannot be overstated. Labeling helps to identify the circuit and receptacle and makes it easier to troubleshoot problems in the future. For example, if a receptacle stops working, you can use the label to identify the circuit breaker that controls the receptacle. You can then check the circuit breaker to see if it has tripped. Finally, remember that electrical work can be dangerous. If you are not comfortable working with electricity, hire a qualified electrician to do the work. A qualified electrician has the training and experience to safely install and repair electrical wiring. He or she can also ensure that your electrical system meets all of the applicable code requirements. Let's discuss some specific scenarios where the use of whips can be particularly beneficial. In commercial settings, such as office buildings and retail stores, receptacles are often heavily used and may need to be replaced frequently. The use of whips makes it easy to replace these receptacles without disrupting business operations. In industrial settings, such as factories and manufacturing plants, receptacles are often exposed to harsh environments and may need to be replaced more often. The use of whips makes it easier to replace these receptacles without shutting down production lines. In healthcare facilities, such as hospitals and clinics, receptacles are often used to power critical medical equipment. The use of whips ensures that the power supply to this equipment is not interrupted when receptacles need to be replaced. In residential settings, the use of whips can make it easier to replace receptacles that are damaged or worn out. It can also make it easier to upgrade to tamper-resistant receptacles, which are required in many new homes. In addition to these specific scenarios, the use of whips can also be beneficial in any situation where it is important to minimize downtime and disruption. It is especially helpful when maintaining electrical connections without interruption is crucial.